Right. Thanks everyone for joining the call today. And we have a few updates and open topics, and feel free to add your name to the meeting notes. And let me paste the link to the note.
This meeting is being recorded.
All right. So the first update is that we added a FAQ section in the Conformance doc, so that anyone who has questions, they can see if it's already being answered in the doc. It's at the very bottom of the page. Nice. Okay, then I want to say that for today, let's target delivering all the musts for the governing board review in September. So after today's call, I think we can start adding the must items to the CNCF repo so that everyone can see what's finalized or the first draft of the requirements in that repo instead of in the doc. So let's go through the open questions, remaining open comments in the doc first. And let me know if it's too small, then I can increase the font size. All right. So last time we talked about the AI framework and operator enablement. And we said that we're going to keep discussing this to talk about what we do with the platform doesn't impose non-standard limits. So I think it could be tricky to test the negative or claim like there's no limit. So maybe we can focus on just making sure that the complex operator can function correctly and reliably in the platform. And then for non-standard limit, it could be making sure that the things like validation webhook of the operator can work, and then you can increase the load of the operator and it can still reconcile reliably. And does anyone have any questions or comments, feedback about this specific requirement? Yeah, go ahead.
So I wonder what's the origin for this requirement? Like, do we have a lot of issues being reported where certain frameworks aren't working well in certain Kubernetes environments? So I think this is really just testing how much compute you have on the platform side and whether it will scale to complex operators, right?
It's not even that much about the scale. It's more about if a user wants to run an AI framework on their cluster, can they do so? So it's a basic requirement for being able to use the operator they want to use in the platform, but without mandating which operator to install yet.
Okay, so I guess this is about some limitations in the platform that prevent the operators from running. So I'm curious if we have examples of the kind of issues that people run with Ray or Kubeflow mentioned
चल
here.
ठीक है यार मैं आता हूँ 11:30 धन्यवाद भाई धन्यवाद
Shivam, your mic is hot.
All right. Cool. Thanks. So for this one, this is not, I do not have specific example platform that violates this, but I think it's a good basic requirement for all the platforms. So perhaps that most or all of the platform already are conformant, which is fine, and we can add more uh, requirements or enhancement to this one later if needed.
Yeah, I guess it'll be tricky to have a test, right? Maybe again, it'll be okay, which ones we pick, and do we run some suite for a particular operator to say, okay, the operator is able to do all the things it needs to.
So for this year, we're not doing test yet, but you're thinking about how do a platform
Yeah, how do we
certify?
eventually have a test for this if we put it in the must bucket?
I think the platform can potentially have tutorial or some local test of installing frameworks. I just pick one as an example. Not saying that everyone should test that. For example, KubeRay. You can install KubeRay in your cluster and then run it, do some basic operation, and make sure that the platform doesn't impose any problems to the installation of that framework. Justine?
And that's like you can't really prove a negative, right? And so I think that is what we do in like conformance and stuff, right? Like we look for where people have made errors or whatever we want to call them, and we like check those things, right? And we will expand the set of things we check when we discover like classes of failures, for want of a better word.
Andre?
Yeah, I think we should definitely, talk about what kind of operators here we discussing, right? Because, for example, like I know at least 4 different ways to run array on Kubernetes, right? It could be AIBricks, could be KubeRay, it could be VLLM, it could be just a little worker set, right? So there are all of things like how this could be tested. Wondering if, this working group should work with the different communities to establish the installation guides or some sort of conformance test from those communities.
Jack?
Yeah, I was thinking something similar. Like, would it be possible to initiate some work that would define like what a conformant complex CRD looks like? So install a CRD on top of an already Kubernetes conformant passing cluster and run some basic functional validation that the CRD is installed, and then that CRD gets tagged as conformant, and then we can sort of inherit that in our conformance effort. Like you have to be able to install conformant CRDs kind of thing.
So you are saying that we don't say which framework, but we use some specific CRDs in the test that's generic for all the platforms.
I suppose that if you were to replace the word complex in that sentence with conformant CRDs, that doesn't exist right now. But if we had a notion of a conformant CRD, then we could carry that requirement into this effort, which is to say you have to support conformant CRDs.
So Mario brought up a point about we're talking about the details of testing. So maybe we focus on what should the requirement be if the current requirement is not clear enough, or are there suggestions for how we can frame the language so that we still capture the goal of making sure that the users, when they want to deploy their AI workloads or use the AI framework, they can do so on the platform without trouble or limitations on Justine.
I think Myrna was first. Sorry.
Oh yeah.
Yeah, sorry. So like along the same lines, so discussion, instead of specific frameworks, can we imagine a test suite which has a sample operator that does the kind of operations that we want to say are supported by conformance? That could be one way out, but I'm not sure if that'll cover it.
Justine.
I think that I think we should as a community do these things, like figuring out like how to better do AI, right? And all of these highfalutin things. That excites me more than some of this conformance stuff, I'll be honest. But I think this is the stick. And we also, like, the carrot is a separate group type thing. Like we are on a tight deadline on this stick, and I think the stick enables us to make progress on the carrots, right? And if we stay focused on the sticks here, and like defining what the requirements are, and we can be a little vague, I think, and evolve them. But let's try to figure out, like, we should agree that, like, a good AI cluster will support operators and these sorts of things, and will have a delightful user experience and shouldn't require a ton of administration and all those things. And I would love, in a group that is probably not WG AI conformance, to figure out like what we actually think are the right answers there. I think this group has to be neutral and come up with broad requirements like that, and they will necessarily be broad, and I think that's okay. And I think we are on a tight deadline in this group, and we should try to just figure out like the broad principles we want to enforce, and elsewhere we can try to determine which one's better and how to do those things and that sort of thing.
I see. So what's your suggestion for this particular requirement?
I think it's totally fine. I think there are some questions about how to test it, and we will evolve our testing going forwards. I think it supports the idea that we want, Kubernetes we want to use Kubernetes operators to make AI easy and great. The details of, I like Ray and you like Kubeflow, we can have in a different meeting or a different vet forum. And I think from a Kubernetes perspective, we want to make them both great. From a working group AI conformance, I think what's there is what we need.
Rita?
Yeah, plus one on the intent of this requirement. I just feel like hearing from all the feedback that because this is still pretty open-ended, I think it may be hard for vendors to self-attest even. Because like you said, right, depending on the operator and what it does, it may be a no. Or so how you say I self-attest, I meet this requirement will be kind of subjective, and therefore I also think it's hard for the approver of this requirement to understand whether or not this is correct. So given that, I think maybe we should move this to a should until we have better clarity.
Would it be super crazy if we suggest a list of common frameworks or operators that could be used to test this functionality if we wanted to keep it as a must? I can see the downside of like being interpreted as endorsing one of these, right? Like we put 2 here, we could build a list of, I don't know, like 10, and then add another similar frameworks, right? So the test would be, to demonstrate that you can install that in your distribution. And yeah, I don't know.
So
What do you say?
perhaps provide some concrete examples you can
Right.
pick from.
Yeah. List of, commonly accepted, similar type of frameworks is, Ray, Kubeflow, Slurm, I don't know, but probably there is a list of 10 largest one or more. And we can also leave it open, like, and similar comparable ones. If we wanted to keep it as a must, but I don't know if, like, what is the reaction to that proposal?
So how does everyone feel that we leave it for now and then add examples of what operator we suggest you use to test, but we don't mandate which one you should use?
Yeah, we can actually, so I think it's a good point actually. So from my point of view, maybe we can say one of these to address, gang scaling problem, or one of these to address training, right? Or one of these to address inference, right? And then platform can decide which CRDs they want to install and test and try out, right? Because I also agree that there are a lot of things which is not part of Kubernetes core and probably will not be part of a Kubernetes core in the near future. So if you would really want to, cover more AI use cases, we should be flexible here.
Sounds good. So I think that's a good suggestions from everyone, and we can move on to the next one. All right, I think it's a little bit okay. Right. The next one is about secure accelerator access. It's a new comment in the doc, so I copied it out. Basically, the requirement is about you should be able to isolate the accelerator access. For example, if you have 2 pods and the pod that requests for a resource like GPU should be able to see the accelerator and use that, but the pod that doesn't request for the resource should not be able to see that.
Janet, I'm sorry to interrupt. I think there are some questions in the chat. Can you just confirm if the last one is a should? Since it wasn't clear.
So the suggestion is that we keep this as a must, but then we provide several different examples of how you might test it. And then I think we can potentially also remove the part about limitation for the feedback about it's hard to test the negative. So focus on testing example operator framework that we provide, and then you can also pick your own if you want, and then make sure that it can function, it can be installed and function correctly on your platform.
Yeah, I still think and I think there might be other people who raise their hands as well, right? I still think that even with the examples, say just because it works for Ray, let's say it didn't work for Kubeflow, what does that mean in terms of self-attestation? Like, does that mean it works for Ray but not for Kubeflow? Is that okay? So again, given these things are not clear, can we make it a should for now? So we can move on to the next requirement.
If I may, like the point of the requirement is to prove that your distribution can support a complex operator, a complex CRD installation, right? So I would like to separate the discussion, like, do we think that that is important for an AI conformant distribution? And then it's hard to test as a separate, conversation. And if we think it's important, then that informs the decision. This should be a must or a should, and maybe the problem is just of how to test it, right? And but we are trying to solve it, or I feel that we are trying to solve it by, for now, it's hard to test, so turn it into a must, but the message turn it into a should. But then the message ends up giving, well, it's the same if you support this or not. You should. It's a nice to have, but if you don't, it's okay. So that is my only concern. I understand we want to move forward, but I wanted to separate those two, right?
Max?
Yeah, I just I don't think it's necessarily important that if a particular component you can install one of them, Ray, for example, but not Q. I think that that's okay. There's going to be new components and things are not going to work. So, but ultimately, I think that if you can show a functioning, you can install CRDs, you can show that they're functional. If you can do it for one, theoretically, there's nothing stopping you from doing it for other components. So, yeah, +1 to demonstrating out of a list of examples or providing your own. Having one is, I think, a reasonable place to start.
I think
Any
there's
other?
oh, go ahead.
Oh, I was just asking any other comments about whether we keep it as a must. We only have 30 minutes left.
I mean, do other people feel like they have enough clarity on how they can self-attest? If so, we can keep it as must. I just felt like this could be confusing for people. I think, go ahead.
Yeah, I mean, I think to me, is the request that we want, like, to encourage CRDs that manage pods, and we shouldn't really care about Ray, Kubeflow, or a batch job or anything like that, right? Is the intention that, like, we're trying to get people away from, like, you can do AI with just like pods. You don't really need a CRD or anything, but I am a little unclear on, like, what our goal for this conformance actually is. Like, there are many people in the wild doing training without these frameworks, and I just feel like, again, we're choosing solutions to kind of self-certify. And I don't fully understand, like, what the point of this one is actually.
Mario?
Yeah, to clarify, we are talking here about vendor solutions. We are not talking about self-certification for individual platforms that run somewhere. We are talking about solutions that are offered by vendors that they show that they can support a certain set of technology and details inside of their Kubernetes-based platform. So the goal is not that private user XYZ or company XYZ is doing a conformant platform in their company. It's basically having an industry standard where we can say, like, we can guarantee that those platforms that you can buy or use from specific companies are conformant to run AI and machine learning workload on.
Yeah, I guess, I mean, okay, but like Spark, for example, like that, someone could use that for AI ML, right? And like, do we include that, like, as job set included in here? There's a lot of ways people can run AI ML workloads, and it's like this quickly can explode. Like all the different options, and even stuff like Kubeflow is bundling job set and other things. Like it just feels like, my feeling would be I should, just because I don't really see any way of actually verifying this in any possibility without it getting kind of too complicated.
So I think for this one, we don't need to think too. So the idea is that we want to make sure that the workloads can be portable. So that's why we want to make sure that in the platform, all the platforms that are conformant, you can perform some basic operation. And we believe that this is one of the basic operation that needs to be supported. And then if the companies are confused about how they test, we can provide examples of here's how you can test it, and then maybe detailed steps before we have conformance. Justine?
I just wanted to call attention to in the chat, Jack Francis gave an example attestation, which I thought was perfectly adequate. Like ran through the Kubernetes installation and blah, blah, blah. Here's the kubectl output to prove that everything works. I think that is all we're talking about. And maybe like a list of 3 or 4 manifests that you can choose from. And like, this is the commands you run to prove it's all running, right? Like, I don't think we need much more than that.
Yeah, sounds good. And I'll take one more question and then I think we can move on. And if there are still concerns after this is being added in the CNCF repo, we can always revisit.
I think I'm neutral on this, but I like the idea that Jack, we just want to be sure that we allow platforms to pick whatever solution they want for these things and not just stick with the top 2-3 names, right? A platform may pick an obscure operator which is not in wide use because that's what they invested in. So just because you used Acme for running your AI workloads, that should still allow you to meet this requirement.
If I may quickly, I think this goes back to the whole distro versus not thing again, right? Like the platform must be capable of installing, let's say, Kubernetes and TensorFlow, or at least one of the two. You are welcome to ship your own Justin's cool AI platform thing, but I have to attest that I am Kubernetes conformant and that you can run other operators even if you don't, for some reason, you don't happen to like Justin's cool AI platform. You should be able to install Kubernetes.
Reasonable.
All right, are we good to move on, or Jack?
Jack's hands up.
I'm sorry, I know it's 35 past the hour, but I just wanted to +1 to the, I think just to clarify my understanding of where we're at now is that platform providers would have the burden of proving one usage instance of something sufficiently complex idiomatic CRD. They don't have to prove more than one. They don't have to show if a particular solution doesn't work on their platform, that doesn't like poison their conformance. They just simply have to prove that their platform can support complex modern CRD operators, or one of them.
Yeah, the requirement is just at least one instead of you have to work. This has to be working for.
I think we can add some more just super specific tweaks in language. Minor will provide that clarity.
Sounds good. All right. Moving on to the next one. For this one, this is about isolated access of accelerators, and then there's there's a concern about this is not supported by all vendors. There's an issue in the NVIDIA GPU operators. So I reached out to the DRA experts and NVIDIA team. So this looks like actually a security hole in the NVIDIA container runtime itself, and they're aware of it. It's being used as a feature as well. So they cannot really remove that. But there are suggestions for how to prevent that kind of access. And Kevin also told me that this is a non-issue with DRA. And then from John, this makes it even more important to have this requirement so that we are not leaving this massive hole open. And then let me go back to this requirement so that everyone can read it. This is about if the pod doesn't request for the accelerator, they should not be able to see it from there, from within the pod. And does that answer everyone's question, or?
Is this about visibility or say exploit through a driver bug? So is it like saying, okay, I requested this particular GPU through the DRA, so I only have access to it. But say if I only requested a mix slice, I don't know, maybe Kevin can answer that better. Is it, if there's a bug in the driver, can I still see things happening on other mix slices through
Yeah, I
that
mean,
access?
I don't think you can do anything about a bug in the driver, but the issue that Janet pointed to specifically is both a bug and a feature. It's this ability for the NVIDIA Container Toolkit to honor environment variables of NVIDIA visible devices to say how, or to say which devices the container should have access to. It's the way that we originally supported device injection to containers on the Docker command line, and it's just kind of been inherited by Kubernetes. If you have the device plugin, you ask for devices using the device plugin, it overwrites that environment variable, and you don't get access to those devices. But if you don't ask for them via the device plugin, and it's just embedded in your container image that you want that this environment variable is set, then in the default configuration of the NVIDIA Container Toolkit, it will give you access to those devices. And so I think what Janet's more getting at is, and that, and like I said, this is considered a feature by some. We definitely don't encourage it. It's not a supported path to get access to GPUs, and we have a well documented way to disallow this. And I think that's more what Janet's getting at in her point here is that, follow the best practices for turning off these bugs/features such that you're always isolated using the best practices within Kubernetes to request access to them rather than going through some backdoor, which is essentially what this is in this case.
Yeah, I think that's reasonable. I mean, as long as DRA and operators are able to support it.
Yeah, actually, one thing to point out there is that it's the way that we currently support what we call management containers or admin access containers today, because there's no real other way to do that without running privilege and then manually injecting a bunch of libraries and binaries yourself. But with DRA, there's the admin access feature that Rita worked on, which allows us to move away from this into a more supported method for getting access to devices without actually having them allocated to the container for monitoring purposes and other things.
Right. I assume that falls under the authorized access part of this language.
Yeah, I would think so.
Yeah.
Yes. So I think we can move on to the next one. It seems like there's no more concerns about this item. The last one is from Andre, I believe, about GAN scheduling to a must. Andrea?
Yeah, I think maybe we can quickly talk about it. Yeah, I think I added this last week, and maybe we can talk here. So I think so from my point of view, I know that today Kubernetes doesn't support gang scheduling out of the box. And I know there is a cap going on within the community to push this upstream. But I just want to hear like perspective from other folks here, because from my point of view, gang scheduling is essential for any type of AI workloads, especially inference training, cry data processing. And we might need to find a way how to enforce this for platform admins to support it out of the box.
So what you propose, is it about moving this whole requirement to a must, or?
Yeah, I propose that we enforce that platform admins are responsible to use any advanced tooling like Q, Volcano, Karmada, or any scheduler which supports gang scheduling for their workloads.
I see. So not specific.
Yeah, because I remember we had some concerns with KQ because maybe some others don't use KQ, right? So we can be flexible here, similar to what we discussed before for AI operators, right?
I think is Jack the first.
Kevin's first.
Okay.
Yeah, I think so. I agree with you, Andre, that I would like this. I think this is I forgot there was a case about like having devices like find problems in GPUs and reflect that in the state. This is kind of more of the case where I think we want this in Kubernetes core, and we're trying to like this should exist somewhere, but it doesn't yet. And I feel like it still should stay as it should, but like we acknowledge that this is a major gap that we have to solve, but I don't think we can put this in a conformance doc at the moment.
Yeah, so I think the point here that if we only put Kubernetes core, then we should, rethink all of the must we define here, right? Because to be clear, like Kubernetes core as of now, not suitable to run AI workloads, unfortunately, right? We'll want to have it, but there are a lot of gaps, which right now we have in core. This is where all these projects exist, right, within the ecosystem. Yeah, so I think like from my point of view, probably without gang scheduling, platform should not offer, like it's hard for them to offer reliable service, right? To run those workloads. Yeah, go ahead, Jack.
Yep. Rita, why don't you go ahead and dial up the vote so we can move this along quick, like you did last time. That was super effective. I think this is really similar to the CRD one. From a user perspective, if I can't run any gang scheduling solution in the entire ecosystem on a platform, I benefit by knowing that in advance and not using that platform. So I think it's a really good stick for platform providers to make sure that in this case, you provide some set of sufficient flexibility in terms of the kube scheduler that gets shipped with Kubernetes so that you can use whatever platform solution needs. If it's a scheduler plugin or an alternative scheduler, like it's going to be different from solution to solution. But I think the point is that to be AI conformant from a user perspective, the user is going to need to know that platform accommodates that flexibility so that you can actually use gang scheduling and actually do the required work that you need to get done. So I would say it's a must in the same sense as the CRD is. Just evidence of a single gang scheduling solution would be sufficient.
Yeah, I think overall, so all of these initiatives should kind of drive adoption of running AI workloads on Kubernetes, right? If you have more shoots, right, at the end, what is the purpose of all of this conformance program, right? We can just continue have the Kubernetes conformance program, right, and slowly drive adoption for those workloads to run on Kube, right? But I think we should be some sort of more flexible here, right? To cover those use cases, important use cases, right? And I hope that also will drive the Kubernetes community to invest more energy to drive this cap forward, right? Because there is a need from users and from platform providers to support these things.
And also for this, the really great carrot for the Kubernetes core gang scheduling effort to get the proper priority so that it gets baked into the actual API.
So I guess I think this is fine in theory, except that we're touching a very passionate part of Kubernetes that's changing seems to change every release. So I'm fine. Like if we say here are the options and we're okay with eventually we might phase out some of these options for other solutions. But I worry that like conformance, we should be a bit more stable. Like, cause like, you know, there is a push in from SIG scheduling to push forward with workload aware scheduling. It's coming up a lot. People want to get behind that. There is concerns about like maybe like host scheduling. There's a reason why we don't want to encourage that in tree and Kubernetes. And there are like a lot of complications with all these solutions. And I mean, if we want to say you should like use some kind of gang scheduler, I guess that's fine. And then we accept that this will probably change in a year or two. And I guess that's where we are.
Yeah, I think so. I think like we discussed it before, and point me if I'm wrong, Janet, but we can break the tests, right? Even after we initially design them, right? And if some of those APIs emerge, we can just refactor tests to, for example, use the core pod group API or core pod set API, right? In the future. And if, you know, when we publish a new version of Conformance, like we kind of, all the platforms need to be aligned, right, with this new test suites, right?
I guess the issue here is what is gang scheduling and does every provider implement the same thing? No.
Yeah, like, yeah, how we will define the test, right?
I think it will be similar to the previous one that we don't mandate which one, but we can provide some examples if the platform needs some way to help them choose which gang scheduling mechanism they want to support.
So, I mean, so would our test be you should use one of these X amount of gang scheduling solutions and then yes, or should we verify the gang scheduling behavior on your cluster? Because to me, the problem is Volcano, workload aware scheduling, Q all have a different take on what gang scheduling means. And they implement it in different ways. So I worry that like this one, it seems like everyone does say, I want gang scheduling. But then if you look at how this is done in every place, and you know, there's auto scaling also has their own version of gang auto scaling. And so I just feel like this is one that gets kind of complicated to actually define what we mean.
Yeah, I think it's a good actually point, Kevin. I think I agree with you that we should build the test suites in a way that it's kind of abstract for the framework. Like, for example, we try to schedule the workloads, and if like for 2 nodes, right, and every node use like 1 GPU, and if, you know, we verify that, you know, the pods will be scheduled only when 2 GPUs are available, right? Or some sort of way, like, or verify that if workload is scheduled, but not all the capacity is available, like the workload won't be scheduled, right? So I think there is a way for us to design the test suite which kind of agnostic to the framework, right? To verify the gang scheduling functionality.
Yeah, I mean, I guess I'm outvoted. So, I mean, if people are want it to be must, then I guess fine. We can figure out a way to test it.
Yeah, I think it's a question we need to answer in the whole AI conformance, because we're only talking about Kubernetes, but in the future there will be other CNCF project as we expand the scope of this conformance. So this will be something that we need to answer anyway. So I think for this one, we're going to add the supporting at least one gang scheduling solution. And I think that's all. That's all of the open comments And the next topic we can discuss is we can review the self-assessment questionnaire together. The questionnaire is over here, and I think after today we can start adding this to the CNCF repo. Okay. Max?
Yeah, I just wanted to double check based on sort of the votes in the chat that the suggestion is to move the gang scheduling to a must, right?
Yes, but not specific about which solution. So this is a must support against scheduling
Got it.
solution.
Cool, thanks.
So the questionnaire will have per product, per configuration of the product, and then the requirement will be in this format, and then you need to specify the status, evidence, and notes. And then I think for the first iteration, we're going to publish must first, and then after that, I think for the next meeting going forward, we can start going through all the shoulds. And then if we still have time, we can even start thinking about all the conformance tests planned for the next year. Any feedback about the questionnaire or any parts that needs clarification?
I guess it will be good if we have the entire questionnaire filled out and folks can review it async. And then if there are still any open issues, we can bring it to the next meeting.
Sounds good. Any open questions about the musts? Mario?
Not about the must, but basically what I before we basically create the whole structure, it would be nice because this is obviously just an example, as we didn't do it for all of the stuff. Just also give feedback on the different points if there's something major missing from the structure for each of the questions. You know what I mean? Not the question itself or not the must requirement itself, but the structure that is below this, if there's anything missing or anything should be added from a structural point of view. For example, I see missing Kubernetes version. That is not in there.
Does the platform version mean Kubernetes?
Yeah, no, platform version means the version of the platform. So for example, Justin's amazing AI platform version 3.4. So we are still missing the version of Kubernetes that we are opting against.
So I think for the questionnaire, we are going to start at least with 134 because of the DRA. But we can add that field here for clarity. Any other comments? Opening the floor for anyone who has other topics they want to discuss. Jack?
This will be a super quick one, I promise. Just kind of a PSA. So Janet and I discussed in the doc the auto scaling requirement, and the language in the doc does not explicitly state DRA, and so we came to a consensus, at least between the two of us and anyone else reading the doc, that is by design. And so just clarifying for everyone out there, auto scaling plus DRA is not a must requirement. So I'm working within SIG auto scaling to accelerate the DRA support in Carpenter. Cluster autoscaler already has support for basic structured parameters. So that effort is definitely ongoing, but just wanted to clarify that that's not going to ship as part of the original conformance spec.
Good point. Thanks for bringing that up. And Rita has a comment about, does the conformance profile need its own version? Yes, it needs a version. I think eventually we want the conformance to be versioned the same as Kubernetes. But because for the first version, we don't have conformance tests yet.
It's still good to have one, right?
Yeah. So any objections that we just called it 134 to be consistent with the first version of Kubernetes that's going to be tied with this. Okay, I think we're going to do 134. Mario.
But then we should agree that we won't change conformance versions for in between Kubernetes versions, because otherwise we will digress from the Kubernetes version in the future. That's the only fear that I have. If we start with 134 and say like, for example, we won't release, we won't change it for 135. And we would only basically, our change would then come for 136, then really the conformance would be 135 instead of 136.
George has a comment about, do we want to commit to that now?
Yeah, like Mario response to yours, like, do we want to keep it very loose and then lock down to a Kubernetes release, or is that worse?
I don't have my suggestion would be we start with 0.1, and once we tie it to the Kubernetes version, we can eliminate the version itself, because then we are stuck with the Kubernetes release process anyway.
Right. Okay.
Yeah, that sounds good. So in summary, we're going to start with something like 0.1 or 1.0. And then after that, after we have conformance tests, we can have it more tightly coupled with Kubernetes releases, because that will require conformance tests as well. And we're at time. Thanks everyone for coming. I think we're making good progress today. We finally finished all the musts. We can all go back and celebrate. Thank you everyone for coming here today.
Yeah.
Thanks, everyone.
Thanks.